Okay, this is section 3.3, and this section is called Optimization with Linear Programming. And this is very similar to what we've been doing in the last section, which was solving systems of inequalities. But this time the directions will say graph the system of inequalities, and then name the coordinates of the vertices of the feasible region, and then find the maximum and minimum values of the given function for this region. So it sounds really confusing, but it shouldn't be that bad. So the first thing we're going to do is you're going to have to solve for y on each of these inequalities. And so the good thing is this first one is already solved. Okay, even though it's backwards. So I'm going to rewrite this. I'm going to write y is greater than or equal to 2x minus 4. So you see I rewrote this one and just put my y on the left-hand side. So let's graph that first. So y is greater than or equal to 2x minus 4. So that means that my y-intercept is negative 4. 1, 2, 3, 4. And my slope is 2, so that means I go up 2 over 1, up 2 over 1. Okay, so whenever I graph this, we should know that this is a solid line. I'm trying my best to be accurate. And I'm going to graph above because it's greater than. So when you're doing this on the paper, you want to very lightly shade in above this graph. Okay, because just like before, when we shade in, we want to see what's intersecting with all of our shaded regions. And this time we're going to have more than 2, we're going to have 3. Okay, so there's that. I'm going to do the next one in blue. So now I'm going to rewrite this equation. When I rewrite that equation, it looks like this. Y is greater than or equal to negative 2x minus 4. So it's that same graph, except I have a negative slope instead of a positive slope. So my y-intercept is negative 4. This time my slope is negative 2, so I go down 2 to the right one, or up 2 to the left one, up 2 to the left one, up 2. Okay, this is also a solid line. And for this one, I'm going to shade above this line. Okay, so when I shade above, it's all of this area. Okay. So right now, what they have in common is this little triangle right here. All right, let's do one more. Y is less than or equal to 2. Now we should know that that is a horizontal line at 2. So 1, 2, it's solid. And I'm supposed to shade below this. So can you tell when I shade below this where all 3 colors are going to intersect? They are going to intersect at this little triangle. Okay, so I'm going to color that in as much as I can so we can see what we're talking about. All right. So I've graphed my inequalities. I'm going to now in black, if you notice, we formed a little triangle here. So in black, I'm just going to color in the vertices of that triangle. Okay, so from here to here, here to here, here to here. All right. So once we graph this, it says name the coordinates of the vertices. So they want me to name this coordinate. Okay, and I kind of messed up here. Let me see if I can do this really. I need to see what these points are. So now that we know where our triangle is, let me kind of fix this. So here's my answer. Okay, and I just kind of erased that because I couldn't see where my x and y axis was. Or where they were, sorry. So this point right here, okay, if this was 0, okay, here's my x and y axis. That point right here is the point 0, 1, 2, 1, 2, 3, 4, negative 4. That's that point. This point right here, that should be the point 1, see, there's 0, so to the right 2, up 1. So if this is 0, to the right 2, up 1. This point right here is to the left 2, up 1. So there's my vertices of that triangle. So now what they want me to do is they want me to take each of these ordered pairs and plug them into this equation. So I'm going to write that down. F of xy equals negative 2x plus y. So let's try this first point, 2, 1. So I'm just going to say f of 2, 1 equals negative 2 times x, and x is 2, plus y, which is 1, negative 4 plus 1, so that answer is negative 3. Okay, now I'm going to do it again for my next point, f of negative 2, 1. So I'm plugging negative 2, 1 into this equation again. So negative 2 times negative 2 plus 1, 4 plus 1, so that answer is 5. And over here I'll do this point. F of 0, negative 4 equals, and I'm still plugging it into that same equation, negative 2 times 0 plus a negative 4, 0 plus a negative 4, and I get negative 4. And they asked you, it says find the maximum and minimum values of the given function for this region. So out of these three answers, what is my maximum value? My maximum value is 5 because that's my largest number. Negative 4 would be my minimum value because that's my lowest number. Okay, so that was number 1 off of your sheet. Okay, so let's do one more to make sure you got the hang of it. This is number 6. All right, on number 6, I first need to solve for y. All right, so I'm going to write down my first equation. 2x plus 3y is greater than or equal to 6. I'm going to subtract 2x from both sides. So 3y is greater than or equal to negative 2x plus 6. And I'm going to divide by 3. So y is greater than or equal to negative 2x over 3 plus 2. So that's my first inequality I'm going to graph. So here's my 0. I'm going to go up 2. My slope is negative 2 over 3, so I'm going to go down 2 to the right 3. 1, 2, 3. Down 2 to the right 3. Or up 2 to the left 3. Again, this is a solid line. And I need to shade above. Okay. So now let's take our second equation. My second equation, or inequality, is 2x minus y is less than or equal to 2. So I'm going to solve for y by subtracting 2x. Negative y is less than or equal to negative 2x plus 2. This is a negative y, so I need to divide by a negative 1. And when I divide by a negative 1, I have to switch my inequality sign around. So now I have positive 2x minus 2. And that's where I'm going to graph. My y-intercept is negative 2. My slope is positive 2, so I'm going to go up 2 over 1. Up 2 over 1. Up 2 over 1. Or down 2 to the left 1. So here's my line. Again, it's a solid line. And it's greater than, so I'm going to shade above this line. Okay. Then I have x is greater than 0. So x is greater than 0 is actually the y-axis. So here's my y-axis. And I want to shade to the right of that. So can you tell so far where my two graphs overlap already? Here's the green and black, so there's the overlapping part. So right now I'm going to just, since it's greater than, I shade to the right of it. So I'm just going to shade to the right where they overlap already. All right. Then we have our last one. Y is greater than or equal to 0. That's going to be your x-axis. It's greater than, so I'm going to shade above this line. Okay, so again, can you see where my all four areas overlap? If I shade above, it's going to be here, but this area right here is where all four graphs overlap each other. Okay, so I'm going to outline that in black so we can tell easily where that is. So it starts here, it goes right here. It's hard to tell. Okay, now this point right here, it looks like I kind of messed up, and I can't tell if it's because my marker is really thick and where that's going to intersect. On your paper, you should be able to tell a little bit better. Okay, so here's what you're going to do to finish this problem. You need to write the ordered pairs of each of those points that I just kind of outlined. I'm trying to kind of get it a little better so you can see it. Okay, so here's our little region that we're talking about. All right, so write down this ordered pair, wherever yours intersects right here, and this ordered pair. And then you're going to plug that into this equation to find your max and your min. Okay, so I want you to finish that, and then I'll look at your answer when you get to class tomorrow. Okay?